star cluster has over 300 B-type stars. Wait, what are B-type stars again? Regardless, this star cluster is 10,000 light years away from us and is over 10,000 times the mass of the sun. But that's just the beginning. On the left, we have the original image, which is our identifier image, showing the full detail and noise of NGC 663. On the right, we have an AI denoised image, which uses an in-app feature to remove noise and background filler from an image. This does change how the image looks, but it is pretty cool. The cluster is located in the center of the image. Obviously, yellow and white stars are visible, and there are also red dwarfs, but some of these are too small to see. In addition, the cluster is surrounded by numerous other stars, which are also yellow and white. We also have NGC 659 sticking out on the bottom left. Now, NGC 659 is another open cluster, similar to NGC 663. Alright, and if you think NGC 663 doesn't have data properties, you are absolutely correct on opposite day. For example, the parallax is about 0.356 milliarc seconds. By the way, a milliarc second is 1/1,000,000th of an arc second. Crazy, I know. And since distance is 1,000 over parallax, the distance of the object is around 2,800 parsecs, which is similar to the 2,950 parsecs measured for the distance. This puts the object at sub 10,000 light years from us. Plus, measurements also show that C10 is moving towards us at a whopping 32.3 kilometers per second. Of course, there's a margin of error, but it's only like 1.2. The metallicity is negative 0.125 when compared to the sun, meaning it's about 75% of the sun's iron to hydrogen ratio. Crazy. The object is also moving its RA in DEC. Its RA is 1 hour, 46 minutes, and 22.2 seconds. Yes, time applies to RA, which is about 359.5 degrees. And the declination is less than 2 million degrees, which means it's approximately 62 degrees, 12 arc minutes, and 53 arc seconds, which is also, when you convert to degrees purely, it is also less than 2 million degrees, sitting at about 62.21 degrees. Since the RA is moving left by about 1.14 milliarc seconds per year, the declination is also moving about 0.33 milliarc seconds down per year. Margin of error for both, by the way, is 0.04 milliarc seconds. Oh my god, how many times have I said milliarc seconds in this video? There are also 791 stars that are the same distance of the cluster, and they're like moving in the same direction. Are they exactly associated with the cluster? Maybe, maybe not. And the exact number of stars for sure is not known for sure, but like the brightest members give the cluster its, picture is about 400. Now that we've learned all this valuable information about NGC 663 that you're gonna forget in about 2 seconds after watching this video, I'm kidding, of course. But here's the thing, B-type stars. That is the main deal about this star cluster. Now, if you don't know, stars are divided into spectral classes ranging from O, B, A, F to G, K, and M. By the way, our sun is a G-type. NGC 663 has a weird number of B-type stars, estimated at over 300. Yeah, I'm not even joking. Some of these stars are blue supergiants, which are O and B-type stars that are super hot and bright and big. This makes the star cluster have a very high mass, lower estimate around 10,000 times the mass of the Sun. This makes NGC one of the most massive star clusters in its region. You know what else is massive? Anyway, although NGC 7419 might be more massive. There's also 5 blue stragglers that have also been discovered. Blue stragglers are stars that were previously red dwarfs that gained energy from other high-mass stars through energy transfer. These stars are hotter and brighter than expected. Only 5 of these supergiant stars and 1 blue straggler appear to have a really high mass, like compared to the rest of the group. And there are also a ton of BE-type stars, which are B-type stars with hydrogen emission lines caused by a gas disk, and these stars also rotate very fast. When 23 BE stars were studied, 19 of them had excess UV radiation. The ratio of BE stars to B stars is around 3 to 10. But alright, why does NGC have so many B-type stars? Like why? What, did they just spawn? No, they did not just spawn. I'm sorry. The full answer is probably more complex, but the current best answer is due to the amount of binary interactions in BE stars. Binary interactions create mass transfers and constant changes, keeping the star cluster alive with tons of B-type stars. By the way, 69.5% of B-type stars are binaries. Nice. Also, the cluster is only like 20 million years old, so most of the stars are pretty young. Alright, and finally, here's the sources I used. Here's an external image I found. And yeah, that's all.